Hello everyone, I am Dr. Prajakta from Rajkot Institute of Management Research and Development, Pune. In previous video, we revised some basic concepts of hypothesis testing. In this video, we are going to learn how to perform statistical tests for hypothesis testing, such as simple linear regression, multiple regression, logistic regression, and correlation technique. Now, what is simple linear regression? Simple linear regression depicts the linear relationship between two associated variables, a response that is called as dependent variable and an independent variable, which can be depicted through a regression equation. Now, this regression equation can be used for prediction of the unknown response variable when we know the value of the dependent variable. The general mathematical equation for the linear regression is given by y is equal to ax plus b, where x is independent variable and y is dependent variable, and a and b are called as coefficients. Now, how to perform simple regression in R? So simply we have to use the function lm in bracket formula and data. Now, to execute the simple linear regression, we have used two variables. The first is cells effort and the second is product cells. In cells effort is nothing but the number of hours of effort put in by the salesperson, whereas the product cells is number of cells closed by the salesperson. Then we create a model relation and we use a function lm y over x and then print in bracket relation. Now, when we execute this particular code, we get the values of coefficients like this. So we can formulate the regression equation as y is equal to minus 38.4551 plus 0.6746x. So this is how it is very easy to formulate simple regression equation in R. The next important command is print in bracket summary name of the model, that is relation. Now, when we execute this command, we get the value of residuals. The residuals actually depict the difference between the actual value of response variable and the value of the response variable predicted using the regression equation. The maximum residual value is given by 3.9775, whereas the minimum residual value is given by minus 6.3002. So, in this case, the spread is from minus 6.3002 to 3.9775. The next section explains the coefficient details. Here, beta 0 is given by the intercept minus 38.45509 and x coefficient is given by 0.67461. So, in this case, we can formulate the regression equation as y is equal to minus 38.45509 plus 0.67461x. The next we are going to learn how to use the predict function. As the name indicates, predict function is used to predict the value of unknown variable from the known variable. The basic syntax for the predict in linear regression is predict in bracket object comma new data, where the object is nothing but the formula which is already created using lm function, and the new data is nothing but the new value of the predicted variable. Now, to execute this particular function, we consider the example of height and weight of a person. So, let's say x is a variable which stores height of the person and y is the variable which stores the weight of the person. If we want to find out the weight of a person when height is equal to 170. So, for this we create a vector called a and we use the function data.frame and we enter the value of the height. So, in this case x is equal to 170. And then we define one more variable, that is result. Then we use the predict function. So, predict in bracket the name of the object is relation and the name of the new data is a. And then we use the command print result. So, when we execute this particular code, we get the value of the weight as 76.22, when the height is 170. So this is how we use the predict function in R. The next is multiple regression. The multiple regression is actually the extension of the linear regression into relationship between more than two variables. In simple linear relation, we have one predictor and only one response variable. But in multiple regression, we have more than one predictor variable and one response variable. The multiple regression equation is given by y is equal to a plus b1x1 plus b2x2 plus b3x3 and so on, where y is a response variable, a, b1, b2 up to bn, these are called as coefficients of regression, and x1, x2 up to xn, these are called as predictor variables. Now we create a regression model using LM function in R. The model determines the value of the coefficient using input data. Now the LM function we have already discussed. The syntax is formula and data. Now in this case, the formula is y equation of y over x1, x2 and x3, and the data we have to enter. So the formula is nothing but the equation, that is relation between the response variable and the predictor variable, and data is the vector on which the formula will be applied. Now for this case, we consider the table empty cars which is already present in the database of R. Now empty cars is the database of car which has the details of different models of the car with MPG, that is miles per gallon, displacement, horsepower and weight. These are the contents of empty cars table. If you want to see the contents, simply enter print head in bracket input, so it will give you top 6 rows of the table. Then we create a model and we use the function LM, the formula and data, and then we print the model. Now once we execute this particular code of instruction, we get the values of different coefficients, the intercept value and the coefficients for displacement, horsepower and weight. So in this case, we can formulate the regression equation y is equal to 37.10 minus 0.0009 displacement minus 0.0311 horsepower minus 3.800 weight. So this is how we can formulate the multiple regression equation in R. Now the next is test of normality. As per this test, the residuals should be normally distributed. In order to check this, we look at the normal QQ plot created using the command plot in bracket model name. So when we use the command plot in bracket the model name, we get the plot like this. In this plot, the residuals are almost on the straight line in the foregoing normal QQ plot. This shows that the residuals are normally distributed and hence the normality test for the residual is passed. So it is very easy to perform the normality test using the plot command. The next is the logistic regression. The logistic regression actually is the regression model in which the response variable has categorical values. It means the value can be true, false or 0 or 1. So it actually measures the probability of the binary response as the value of response variable based on the mathematical equation relating it with the predictor variables. Now to perform the logistic regression, we use the command glm in bracket formula, data and family. Now what do you mean by formula, data and family? The formula is the symbol presenting the relationship between the variables. Data is the data set giving the values of these variables, whereas the family in our object to specify the details of the model. Its value is binomial for the logistic regression. So by default it is binomial value. The inbuilt data set empty cars is already there in the R. So it describes the different models of the car with their various engine specifications. Now in empty cars dataset, the transmission mode is either automatic or manual, and it is described by the column AM, which carries the binary value of 0 or 1. Now we can create a logistic regression model between the column AM and remaining 3 columns, that is CYL, that stands for cylinder, HP horsepower, and WT for weight. Now how to create the regression model? So we use the binary function, that is am.data, and then we use a function glm in bracket formula. So formula of am over remaining 3 variables, that is cylinder, horsepower, and weight. Data is equal to input, and as I mentioned earlier, family is equal to binomial. When we print summary in bracket am.data, so we get the output of residues. So here the residual values are: maximum value is 1.27, the minimum residual value is minus 2.172, and then the next section explains the coefficient values. The intercept value is 19.70, then the intercept for the variable CYL is 0.4876, coefficient for HP is 0.03259, and for weight it is minus 9.1494. So this is how we can easily create the regression model in R. The next is correlation analysis. The correlation actually specifies the way one variable is related with the other variable. In R, we have to simply use the function COR for performing the correlation analysis. The value of correlation coefficient actually falls between -1 to +1. So +1 shows the perfect positive correlation between two variables, whereas -1 shows perfect negative correlation between two variables. We have defined two variables, that is x and y, and then we have to simply use the function COR in bracket x comma y, and we get the value of correlation coefficient as 0.977. So as you can see, there is a very high correlation of about 0.977 between the heights and weight parameter, as well as if we perform the correlation on the product sales and sales effort data, we get the value of correlation as 0.999. So it again shows a very high correlation between product sales and sales effort. So in this manner, we can perform various statistical tests for hypothesis testing. I hope this video is useful for you. Thank you.